so that you also see how it works. If I use the transducers, you can see it's too high because it's closed. Then you have a calibration, and this calibration is only for, let's say, in-house. Before I go to construction site, I use this. Okay, my instrument is working, and then I go to the concrete and I do the calibration more or less on the concrete. Because on the concrete you will see if you have a, let's say, 12 centimeter wall or 20 centimeter wall, then it's okay. You key in, you can key in here distance, transmission time, and then you key in here 20 centimeter. Then you check, then you know the velocity, you change it to distance, and then you check with this velocity if you get a 20 centimeter, 200 millimeter. Then you have done the calibration on the concrete, and you know that the velocity is correct, because this is plastic. This is just to get the function, if the instrument is working well. So I wanted to show you this just before we go to the presentation, that you have an idea how it looks like on the instrument. Going back to presentation. I think it was explained in your language, so I go through. You see the formula. What you have seen at the chart from the norm is more or less, we talk about 3,000 to 5,000 meter per second. Good to know is 5,000 to 6,000 meter per second is usually steel. So if you have a lot of rebars in, you get a high speed. Okay, remind yourself, steel has a higher velocity. Then you can say, okay, I check it somewhere else on another point. If it is all the time the same, still the calibration is done on the concrete on site, then the steel is included. Just to give you a short introduction next to Mr. Tadayon's explanation in Farsi, P-wave are the fast ones. They go this line. If you have the shear waves, what you have on shear wave for E-module, elastomer checking, or on the pulse echo, we talk about shear waves. They are bouncing, and they are slower. I heard direct, indirect, and semi-direct. Those are the pictures for it. I don't explain. Yeah, I thought because you have explained. Yes, you will see later on when we talk about pulse echo. This is the best way, and if this length is longer than this one, it's better, because otherwise it can bounce and you get extra noise. So when you have a small cube, or you drill the core and you test it, and if it is too long but it's just small, you will get extra noise, so the calibration will be not as accurate and the results will not be as accurate. This one, I will show you a picture later, because if you use it this way, maybe there's a rebar, then you get this connection, then we don't talk exactly about the homogeneity of the concrete. Same over here. Like you see here, if you do direct, and then somewhere is a metal part like a rebar, you will get some extra connection. Steel is the better connector than concrete. Concrete is like a resistivity.
این فرمول تصحیح است که بله توی PS 1881 پارت 23 که من حالا اینجا هم
This is following the British standard.
این فرمول تصحیح به اصطلاح اون وجود میلگرد هست، یه فرمول پیچیده است و در واقع حالا چقدر هم درسته یا نه بالاخره PS 1881 داده که اینو اصلاح کنیم. اون وقتی میگه خیلی طول زیاد میشه اولا این تصحیحات خیلی دیگه جوابگو نیست.
So coming back to SONREP, to use ultrasonic to get the compressive strength, you have this curve, and then, like you have seen first at the chart, you get, because of the speed, you get more or less the compressive strength. This is working together the best way. SONREP is also standing for sonic, ultrasonic. REP is standing for rebound. That's why it's called SONREP. It's a combination of a test with the Schmidt hammer and a test with SONREP, with ultrasonic, sorry. You have this formula, what you can key in on the ultrasonic device, and then you get the numbers. I will show you. How? You see, from an example here, done. The correlation is 0.71. This is done with the Silberschmidt or original. Schmidt hammer is here, and here is ultrasonic. Here you have the UPV. Ultrasonic, you have 0.71. So it's more or less 70% from your result, 100%. Here we talk about a correlation result of 78%. But if you combine, you will have a correlation of 88, what is much better than just one of them. You get a better correlation. Like we said before, you have first with the Silberschmidt just outside the top surface, and if you use the ultrasonic, you get also the inside, so that you see the homogeneity. The chart from the norm was quite nice to see which numbers of meter per second, which velocity you need, and then you have the compressive strength. You will see later on the second part with the pulse echo that a crack can disturb your results, a void can disturb your results. So what is needed is you just don't do it on one point. You use it here, then you go somewhere else, you test again, and maybe you check first the grid of the rebars, so that you make sure you're in between the rebars and not exactly on the rebars. So how you can create your own, there are three options. The option one uses most of the time, but you will get out the biggest experience. Why? You do your curve by yourself. So you get more experience about your concrete, and you know what is happening. But it is not useful for every construction site. But you get the best results. Option two, there are quite a number of existing curves from globally seen from everywhere in this world, so you can use them. And you can Google them, you can get them down, and then you can key in the values. You will see. The best is use more of them. You check what is matching to this, what you expect on result, and then you say, okay, you will see on a slide, okay, I take this curve because this is not matching with my values. Or the option three, you just take the SONREP curve, what is a very standard one, and then maybe your results are not as accurate as you want to have it. When we talk about the option one, you just do tests with the Silberschmidt, you get value, the Q value, and you take the average. You use the Pundit Lab or the Pundit PL 200, you get an average, and then you get an estimate with the formula what we have seen first. You get the estimated average compressive strength of here, like here on 29.5 Newton per square millimeter or megapascal. How does it look like? You just do some tests. So you can see on the next picture, you can see on the Excel sheet, you just key in the results from 16 cubes, what you have measured with ultrasonic and also with the Silberschmidt. Then you key it in the Excel sheet, and out with the formula you will get the results that you have created, so that you have created your own curve with these numbers. Because this you can key, those numbers you can key in with like constant A, B, C, and the square value R on the formula what you will see on the settings. Like here. You have A, B, C to key in, and then you get the formula done. And here, with minimum and maximum of the valid range of the velocity. You can see here with the red frame, and on another red frame. So this is for the settings. Option 2, I would say all the time this, that you start with this. Why? Those curves and formulas have a lot of experience behind. So if you start the first time with this, just use one of them, or you can Google after them, and then you get all the values. You take it, you check it out, you take another Excel sheet so that you do with this, let's say you use the RILAM and the Leo, and then you check the results. Is it close to this what you expect? Yes, okay. This one is not close, delete. But you get the information out, and then if you have the experience of this test, of this kind of test, then you can create yourself a curve. Here you can see RILAM, DeLeo, you did your tests, you key it in an Excel sheet, you get the values, which is better, then you take this what is matching better for you. This is how the curve then look like on the SunRep curve. You can key it in on the ultrasonic device, on the P-Link software, and then you key it in, and then you get this curve, and you use it. And how does it look like? Or you have already copied one from another instrument, then you just say create copy, and then you use this. For the practice, if we come to the Pundit Lab Plus, you have to be more experienced with the A-scan, because you just get numbers. You get the signals, of course, but you have to read the A-scans. And you will see later on what is the A-scan and the B-scan. B-scan is just, A-scan is the methodology, B-scan is a picture out of the methodology, of the A-scan. Here you have, this is keyed in, here you have the SunRep curve, and then you get the result. And this is the rebound number, what you have keyed in, and then you get the results. Like here, it's 53 megapascal. When we have a look on the new instruments, it's a bit easier to see. Did I take the correct curve? I get this result. Did I key in everything nicely? Okay, otherwise I still can change it. This is for the SunRep.
اجازه من یه توضیح بدم. ببینید ما قبلا گفتیم که یک کالیبره انجام میدیم برای مثلا چکش، کالیبره مقاومتی، یا گفتیم یک کالیبره انجام میدیم برای التراسونیک. چیزی که تحت عنوان سانرب در واقع مخفف سونیک ریباند هست به کار بردن، اینه که در واقع نشون دادند که یک به اصطلاح مدل های ریاضی میتونه برقرار باشه، حالا که مقاومت ما مساوی است با یه ضریبی در اون نتیجه ریباند چکش به یه توانی ضرب در سرعت پالس به یه توانی که اون ضریب A و اون توانان B و C هستن. چنین مدلی برقراره. حالا شما میتونید در واقع یه چنین مدلی رو برای بتوناتون بسازید توأماً با آزمایش چکش و چی؟ التراسونیک. یعنی این دفعه از هر دو استفاده کنید. گفتن که نشون داده شده در که وقتی که شما از هر دو استفاده میکنید مدلتون خیلی به اصطلاح نتیجه های چی میده؟ بهتری میده. بنابراین از این استفاده میتونیم بکنیم که نتیجه های تخمینی بهتری رو، دقیق تری رو در واقع داشته باشیم. و این کار رو این دستگاه برای ما، دستگاهی که الان این دفعه درست کردن، یعنی اون چکش جدید، بله چکش جدید و این دستگاه التراسونیک میشه این اطلاعات رو داد و نتیجه ازش در واقع گرفت. در واقع این کمک رو به ما کرده است. خب اگر سوالی هست که بفرمایید، اگر نه که مثل ظاهرا پذیرایی فکر کنم یه رو بیام دیر شد.